Okay, so we are discussing about the specification for the product, or how do we develop the design specification for the products. And we saw that once we have the customer needs, identify these needs based on some standard methods, and then for each and every need you can identify a metric. A metric is something which is quantifying the customer need. So customer has got particular need which is very subjective, so we are converting that into an objective measurable quantity which we call it as the metric. And one important point is that for each and every need you need to have a metric. If you don't have a metric for a particular need, essentially you are telling that I cannot convert that into a quantifiable thing, and therefore I don't know how to design for it. So for each and every need you need to have a metric identified. And once you have this metric identified, you prepare a need matrix by providing the needs and metrics and their relative or the relationship between the need and metric. So effectively you need to identify how many metrics can be identified for each need and how these metrics are connected to the need. How strongly they are connected or how weakly they are connected can be identified or can be represented using the need matrix. So this was what we saw in the previous class. And the importance of the needs and metrics can be identified. And what we need to do now is to identify the target values for the metric. If you say it should be the weight is a metric, we need to know what is the value of that metric which can be provided in the specification. What happened? Okay, so the target values, how do we get the target values is the question now. This is what we are trying to answer here. How to identify the values for the metrics so that you can set the target values for the design. You can say the weight should be less than some value, or the time to assemble should be less than X seconds or T seconds. That is what actually we need to identify, and then we can design to meet those specifications. So let us see how to identify the the values. So one of the most commonly used method is known as benchmarking of the products with the existing products, or you try to benchmark the parameters with the existing products. So this is the first step in identifying the values. For example, you are talking about the cycle which we discussed in the previous class. So we are saying that the time to assemble is a metric. Time to assemble is a metric, and then the customer need associated with this was easy to assemble. So easy to assemble was the need, and the metric was what happened? Okay. So the metric was time to assemble. Now we need to find out what should be the time to assemble when you design the cycle or the fork assembly. What should be the time to assemble? We need to set a value so that we can design the product in such a way that it meets this requirement. To do this, first thing we need to do is to benchmark the need of the customer with respect to with other products, existing products. So what we do, we try to identify few existing products to benchmark. So say this is a Hero cycle, so this is Hercules, this is Raleigh, some brands. So we know that these people are making bicycles and customers use the cycle, but still they say it should be easy to assemble. So now you benchmark this particular need. So we say that easy to assemble is a need. Easy to assemble is a need. Now we want to find out how easy Hero cycle is easy to assemble, how easy Hercules is easy to assemble, how easy it is assembled to the Raleigh cycle. So first we'll look at this needs as a benchmark. We benchmark on the customer needs and then say that Hero gets 5 stars because that is the easiest one to assemble. So we give some star values. Okay, it is the most easiest cycle to assemble. And then we look at Hercules, then we'll say, oh, okay, it is very difficult to assemble, so give it 2 star. Some comparative value we give. And similarly, we'll give, oh, this is too difficult to assemble, so, or we'll say that okay, this is 3 star. Like this, if you have more, you can actually give some values for here. Okay, so this way, you identify each need of the customer and then try to see what are the ways in which these products satisfy the customer. Because the products Hero, when Hero has got a product and customers are very happy with this product, they are saying it is 5-star rating, so it is very easy to assemble. And rally cycle is not that easy to assemble. You need to understand that when you design something, it should be equal to or better than this. So that is the understanding that you need to get from the benchmarking. So you look at the existing product and try to find out which one is satisfying the customer needs in a better way. So this represents the satisfaction of the customer with respect to a particular need. Similarly, cost. You can say low cost is a customer requirement, customer need. Then you see which one is which cycle actually satisfies this customer need. Then you will see that Hero cycle, it is very costly, so probably customers are not that happy. But probably this product, it is low cost, so it is very satisfying the customer need of low cost. Similarly, you will see something like this. So this way, you can actually benchmark each of the needs against the existing products. So this is the first step in benchmarking or getting the target values for the products or the metric. So what we are trying to do is to look at the existing products and then see how these products are satisfying the customers, how well they are satisfying the customers, and based on that information, you add this value, this rating, and then try to find out who actually satisfy this product very well or this requirement very well. So what we get from this result is that we know which product is satisfying the customer very well, and then we can look at what is the value Hero cycle is using for the easy to assemble. So how much time it takes to assemble Hero cycle. So we will get some value, say that okay, it is 15 seconds, some example. So I say this is 15 seconds and this takes maybe 25 and this may be 20. So we will be able to identify these values from the products, and then we can say that okay, since we have to make the cycle easy to assemble and existing products are using these values, either you have to use the 15, the minimum what is there, or maybe less than that. So that is some understanding that you can make. Your product should be, the target value should be 15 or somewhere near to that, depending on what actually you are looking for. So this is the way how you get the target values or the ideal values for the metric. That is known as the benchmarking to get the specification for a product. Got it? So what we do is we look at the existing products, try to find out how these products are satisfying the customer needs, how well they are satisfying the customer needs, and then try to take the values that these manufacturers use for the particular metric and try to see whether that can actually be used as your target values. Not necessary that you should always use their values. That depends on many other factors. So you can say that, okay, though the customers are asking for low cost, does not mean that it should be always the lowest among the market. You can decide, provided based on the values, you can decide where actually you want to fix your target values. So that is the way how you go with the values for each metric. Got it? Any questions? All right. Yeah. Pardon? Yeah, that's what. The initial pride, there is no metric per se. That's why the subjective metrics can be used. Okay, there is no value for that. So in some cases, very special cases, you use a subjective matrix, instill pride. So there is no value. So that is basically coming from your brand name and your many other things which you use. So it cannot be part of the design per se. Okay, you cannot have it actually as a part of only the design. It comes from many other fields. But we'll add it as a customer requirement and then say it's a subjective one. Then we'll leave it like that. No need of benchmark. Benchmarking you can still use, but then you don't have any value to use it. Benchmarking, you can say which one actually gives you higher pride. So you can say, oh, Hero gives you higher pride. Then you can take that as the best one and then see what are the features they provide to make the pride for the customer and try to bring in that one as a separate entity, not as a particular specification in the product. Cost need not be always instill pride. Okay. Because instill pride, of course, the cost should be always high because of the features they provide. So cost need not be always a direct relationship to instill pride. Okay, yeah. So it's brand value is one major thing, but brand value you cannot bring as a design specification. Yeah. Oh, okay, yeah. I'll come to that because then we need to analyze all these. So first we'll say that, okay, these are the values they use. Then you need to decide what should be your value, because you will be having a target customer, and based on the target customer, you need to fix the price, or you need to have two versions of the cycle, one for the high cost and one for the low cost. So that is to be decided based on all this information. So this stage we are trying to collect all the information and then put them everything into a proper what you call an analysis tool, and then decide what should be the value. So here we don't directly decide the value. We will say, okay, this person is using this value. That's all we are telling. What should be our value? We need to take a call on based on many other features. Any other questions? Okay, so I'll give some example. So last time we discussed about the customer needs for the suspension, for the bicycle suspension. Then we found that the reduces vibration to the hands and similarly allows easy traversal. All these things are the customer needs. Lightweight, instill pride. You can see that there are many companies which actually make suspension fork for the mountain bicycle. So you can see which one is actually satisfying the customer. You can see this one 4-star and this is 5-star. In some cases you have some particular needs. You can see for reduces hand vibration, this seems to be the best one, ROX and TA. And for instill pride, you can see these two are, this is the best one. So here also it is the best one. So like this, you can identify which company provides you the maximum satisfaction and then try to see what values they use for each one. So it's not necessary that only this value, you can find out the value, whatever is available. Sometimes all the information may not be available, so you need to make some assumptions. But we will try to get this information and see who actually satisfy the customer needs in a best way. For example, last long time, you can see this one. Most of them are actually good. I mean, except for this, the life of these all are good. But this one, the life is not that good. So if you try to improve upon this and try to provide all these values, you will have a better than this product. If you want to make it better than this product, you can actually go for it. So like that, you will get an idea what are the ways in which the customers are satisfied with the existing products, and that gives you a rough idea of the value to be used for various metrics. Okay. Now we try to get the values here. So now we move to the corresponding metrics. So each need there was a metric. Then we try to find out what is the value that these companies are using for each metric. So one metric was attenuation. So you can see that it is 15 dB attenuation here, ROX, and that's why it is satisfying the customer very well. And this is also using 15, and some of them are using 8, some of them are using 9, etc. So you have now an idea. If you want to design a bicycle, if you want to make it better than this, then you need to go for a better value than this. Or you are looking for a cycle in this range, then you can actually decide what should be the value. You can say it should be the maximum 15 or it can be a minimum of 8 need to be provided. So this is the way how you can decide about your target values. Each one you can see the total mass. This company, this weight is around 1.364, but this is 1.222 only. So less the weight, the better the satisfaction of the customer. So now you need to decide if you want to go for this, and this weight is, this is the weight, whether you can have for this or you want to have a different weight. So it varies from 1.1 to 1.4. So that is the range of weight that is normally provided for this. Then you can take a call what should be the approximate weight that you want to have for the product. Similarly, each one you can see what are the parameters they use: the wheel sizes, tire width, time to assemble to frame. You can see this is 45. Okay, and this is also 45, and these are 35, 35, 35. So all these are using 35, where customers are more or less satisfied, not very high. And this uses 45, it's actually satisfaction may be less. So you can decide to make it 35, or you can make it 45, or you can make it less than 35 also, so that customers will be more happy. But it may not be always possible to have a very random value like that. That's why you need to look at these values and then take a call what should be the approximate time you can consider for this particular metric. For like this, for each metric you will be able to get the values from the competitive benchmarking. So this is known as competitive benchmarking, and based on this you can get the target specification for your product. So whatever may be the products, we need to identify the metrics and then benchmark this with respect to the other products in the market, and then find out what should be the value to be used, or what should be the range of values that you can use to get the customer satisfaction. When it comes to design, you may not be able to provide all these, but you know if you go beyond a particular value, the customer won't be happy, and therefore you need to make sure that you are able to meet these specifications. This is the way how you get the target values for the products. Okay, any questions? Able to follow? All right. Okay, so we got this values. So you can actually have an ideal value, which you say that, okay, this is the ideal I would like to have, but then you need to have a marginally acceptable also, because may not be always able to reach. You can say, okay, my time to assemble should be 30 seconds, that is the ideal value, but then I'll be happy if I can get between 30 and 40 also. This is ideal, the lowest I would like to have, but if it is within 40 also, I am fine. So that is basically known as the marginally acceptable values, where you at least x or at most x, between x and y, exactly x, like that. So that is basically known as the target values. So ideal value is the one which you prefer to have, but because of the design constraints, you may not be able to reach the same, but you can say that, okay, 30 is my ideal value, but anything less than 40 I can accept. So that is what we call it as marginally acceptable value. Now, once you have all this, you have the design specification ready for the product. Each one, the number of tools, you will be saying number of tools should be less than 3. Ideally, it should be 2, but less than 3 is fine. Okay, time to assemble could be 35 seconds, but anything less than 40 may be acceptable. So like this, each and every metric you will be having some value, and then you are saying, if I can meet these values in the design, then I will be able to satisfy the customers, because it came from the customer needs. So if I can meet these metrics or the values, then I will be able to meet the customer needs. So that is the fundamental understanding in making this the values, that finally if you meet these things, then the customers will be happy with the product. So that is the ideal and marginally acceptable values for the metric. Okay, fine. So this is the way finally it will look like. So now you are saying that this each metric, you will write each metric and then say this is the metric and these are the needs which the metrics are satisfying, and now you say okay, these are the marginal value and this is the ideal value. Okay. So 15 is the ideal value, you would like to have the attenuation of 15 dB, but 10, anything with, about 10 should be always good. You should not go less than 10, then you will not be able to satisfy the customer needs. Similarly, everything you can see, the wheel sizes, 26 inch is the ideal value set, and here you can see the total mass should be less than 1.4, preferably less than 1.1. So 1.1 was the least used by the competitors, but if you are not able to get it, at least make sure that it should be less than 1.4. Okay, so like this you will be able to get all the values for the metrics, then your specification is complete. So this is known as the specification for the design, or design specifications for a product. So we start with the customer needs and then identify the metrics corresponding to each need, then try to find out how these needs are satisfied by the competitors, and then based on that what value the competitors are using, you decide your design values, and that completes the design specification. This is adjustment range. It's not coefficient. So whether you can adjust the damping within the system. I mean, is it an adjustable one or a fixed damping coefficient? Okay, so you would like to have an adjustment, okay, but even if it is not adjustable, it's also fine. So see, every shock absorber will be having a set value already designed. Whether the customer can adjust the value or not is the question here. So if customer can adjust, it will be good, but if the customer cannot adjust and it already meets all the requirement, that is also good. The customer can decide, depending on the road which he is traveling, the damping coefficient to be varied. Okay, so whether you can vary it or not is the question here. So you are telling it cannot be varied, it can be varied. So if you can vary this, that will be good, but even if it is not varying, that is still acceptable. Okay. All right. So now, finally, with all this information, you need to find out few things, because now you have all those information and you have to see which are the customer needs very weakly satisfied by your design. I mean, based on your metrics and values, you have to find out which are weakly satisfied and how they are depending on each other, because some of the metrics you may try to improve, then other metric will get affected. Okay, if you want to reduce the weight, then the strength will go down, but you want to increase the strength and reduce the weight also. So there may be some kind of interdependencies or interrelationships. So we need to find out which one is actually going against our requirement or against our expectation, and then what product changes can affect to improve these weak points. So what are the weak points and how do we actually improve upon these need to be identified. So this we need to do on a particular way, that is known as reflecting on the results, and we use some standard tools to do this, and this is known as house of quality, or we call it as a QFD, quality function deployment. Okay, quality function deployment is basically a tool normally used in many other fields also, not only in design, and we use this tool to analyze this and then find out all the interrelationships between these needs, and finally to say which one I should really touch and change, which one I should not touch and which should not change. So that is basically the tool QFD helps us to do. So we will look at this QFD, and one of the QFD tools is known as house of quality. So we use this HOQ or house of quality to analyze the metrics, values, and the competitive benchmarking. Everything we'll try to put in one single page and then see which one is going against us, which one is in favor of us, and what changes to be brought in the product in order to make it more and more user-friendly or satisfying the customer needs. So that is basically the next stage. So in the specification development, the first one is to get the metric. So we saw that first one is to identify the metric, and then you do this and get the need and metric relationship, and then look at the benchmarking to get the values. So values will go do the benchmarking, identify the ideal and target values. So once we have this information, we'll try to put it in a more comprehensive analysis tool, which is known as house of quality, and try to find out how they are, whether they are satisfying properly or what kind of interrelationships are existing, and then decide which one we should try to adjust or change in the product to get a desired customer satisfaction. Because you won't be able to make everything change, because when you change something, the other one will go against you. So you need to find out which one is the right metric to be controlled in order to get the desired performance. That is basically analyzed using the tool called house of quality. So before going to that, let me talk about the midterm examination. So your midterm examination will be held on 12th March, which is the closed book. 12th March is Thursday, and 11th March you need to submit the, there will be two parts. So part A is an open book exam and part B is a closed one. I already given you the mark distribution, the beginning. So you will be having some marks for the open book parts. You have to submit as an individual reports, and this need to be submitted soft copy on 11th March. Then 12th March you need to give a hard copy and then write the exam here. So this is the schedule for your midterm examination. So I will be releasing the question for the open book exam on 5th March. 5th March is this Wednesday. So this will be available on Moodle. You can visit Moodle site and then check the question. Questions will not be the same for everyone. There may be differences. And you need to submit the report on 11th March. So the report is basically, it will be a design problem. The question will be a design problem. You need to go through all the steps what we learned and what you practiced in the lab. Same steps you need to follow and then bring the report, a design report for this. It will be covering the design specification, including the house of quality. That is going to be the open book exam, and closed book will be more or like a conventional examination. Again, based on whatever you learned, there will be questions. So if you have done this very well, you have done it on your own, then writing this exam will be very easy. Okay, so let us see how do we actually develop the house of quality. Okay, this quality function deployment transforms customer needs into engineering characteristics. So that is basically known as the QFD. So the voice of customer or the customer need is now completely converted to engineering characteristics. Now no more customer needs are there. Everything we convert into engineering parameters, and then you look at how these engineering parameters can be adjusted, modified to make the customer happy. So that is basically the QFD. And while simultaneously setting the development targets for products. So what could be the development target or your target specification for the product is decided, is done in the QFD. So this was initially developed by Yoji Akawa and first applied in 1970s by Mitsubishi in their product development. Now most of the companies use this tool in order to, when they start a new product development, they try to use this tool in order to understand the whole spectrum of customer needs, their importance of the needs, then the metrics, the importance of the metrics and how the metrics are related to the customer needs, and then how the benchmarking is done, who are the competitors, what are the values they use, how do they satisfy the customer. all those things are put into one single tool, and then you try to analyze what should be your design goals. That is basically known as the quality function deployment. So in this quality function deployment, we use the graphical representation called house of quality. So this is known as house of quality as a graphical representation in order to have a clear summary statement of the product specifications and supporting data consisting of benchmark, target values, technical difficulty, etc., etc. So what we try to do, we summarize all the information whatever we collected so far, put it into a graphical representation which is known as house of quality. And this graphical representation helps you to understand all the information in a single sheet. So all this information whatever you collected so far can be put into a single sheet, and that can be used for analyzing the design goals and then deciding the specifications, or deciding the design goals that we need to satisfy in order to satisfy the customer. So that is known as the house of quality. So why this is known as house of quality? Okay. So what we do here is, so what we need to do is, we try to write down what is needed in the product. So what is needed in the product is decided by the customer needs. So this is known as what is needed. So customer needs are there. So that is what is needed in the product. And then we'll try to find out how important these needs are. So what is needed and what is the importance of each need, we try to put down as a graphical representation, and then see how to achieve this customer needs. So this is known as how to achieve the customer needs, and this is the matrix. So now we are telling these needs can be achieved through this matrix. Less cost can be achieved through some of the metrics that you use. Low weight can be achieved through some of the metrics that we use. Then we try to see then we will write down the relationship between these metrics and the needs. How they are related, how strongly they are related. So you have many metrics here. Now there is a need here, need 1. I will say, okay, these two metrics are related to this need. Similarly, this one has got a strong relationship and this has got a slightly weak relationship. So these two metrics, metric 1, 2, 3, etc. So metric 1 and metric 4 are related to the second need, need 2. So by changing these two needs, I will be able to control the metric 2. Sorry, the need 2. And if I make changes in this one, it has got a very strong relationship, so it will be very fast, it will be changing. This has got a least influence or less influence. So this way, I will try to get the relationship between the metric and the need here. So this is known as the relationship matrix. So you will be having a relationship identified in this part, which actually talks about the relation between needs and metrics. Now, we want to know what should we change in order to, or what should we do with the metric in order to get a improvement in the need. For example, if this is the low cost as the requirement, customer requirement is low cost, and we know the cost of the product is the metric. Cost is the metric, and we know that we need to reduce the cost in order to get the product satisfaction or customer satisfaction. So we write the change in the direction of change what is needed. In which direction we need to change the metric to get a satisfaction. Similarly, if it is time to assemble, then time will be a metric. So if this is the metric which is time, we know the time should be reduced. So we put an arrow to say that it has to be reduced. So this way, we'll try to identify the direction in which the metric to be moved, whether you want to increase it or you want to make it the same, or you want to decrease or increase. So for each and every metric, we'll try to identify whether something has to be increased or something has to be decreased or something has to be maintained the same way in order to satisfy the customer. Time to assemble, we know that the time has to be reduced. Similarly, you have to have the number of tools. You know, number of tools will affect the, number of tools should be metric. So the number of tools will be a metric which can be identified here, number of tools, and that also to be reduced. So we write that, we put an arrow saying that, okay, this has to be reduced. Now, this is what is to be achieved and this is how to achieve, and in what direction you should change to achieve this is done here, and how they are related is done here. Now, we need to get the values. To get the values, what we do, we try to do the benchmarking here. So we try to find the benchmarking using the competitors. So competitor 1, 2, 3, 4. So you have competitor 1, competitor 2, competitor 3, and whatever we saw in the previous section, we try to find out which need is satisfied highly by this particular customer. So you can put it as 2 star, you can put it as 4 star, or whatever the stars you want to give. So we are trying to bring in the benchmarking information also into these charts. So we know that who actually satisfy these values properly. I mean, customers provide the satisfaction. So we have, okay, for this particular need, this company is the best. Now we use what is the value these people are using for each metric. What is the value the competitors are using? So this is the value of the competitor. So we have the competitor 1, 2, 3, 4, etc. Try to find out what is the value they use for each metric. Again, we saw that how to get these values. So here we give the customer satisfaction. Here we try to get the values of the competitor. Okay, so whatever we saw in the previous class, slides, we are trying to bring everything into a single sheet. So the needs here, the metrics here, the direction of change here, the competitors satisfying the customer needs here, and the values of the competitor also here. So everything is there in the same diagram. Now, based on this, you have to decide what should be your target value. So look at this satisfaction. If that is one company is satisfying a particular customer need very well, look at there what is the value they are using for the corresponding metric, and then decide what should be the target value you have. Okay, then we'll have one more thing to say, how difficult it is to change the metric. Difficulty. Because some metrics are easy to change, some metrics are difficult to change. So which one is easy to change, which one is difficult to change? We try to identify here the difficulty level of each and every metric. Easy to change or difficulty level in terms of some ranking, you can give how difficult it is to change. So why we need to identify this is to see which metric can be easily changed to get a customer satisfaction. So that is known as the difficulty level. Now, based on all these values, we will be able to get the target values can be obtained from this chart. So we have needs, metrics, competitor values, competitor satisfaction, and competitor values here. The last thing what we need to know is, if I change this metric 1, suppose I increase the metric, I have given this as a metric and I want this to increase, what will happen to the other metrics? Is there any other metric which will get affected by changing of this? For example, I am saying the cost, the time to be reduced or the weight to be reduced. I put it as the weight. Weight is reducing. If I try to reduce the weight, is there any metrics going to get affected by this? So what we do here is to have a correlation matrix here to see if I change this one, is it getting affected, any one of the other one getting affected can be shown here. So, if by increasing this, if this is getting affected, the cost is getting affected, I will say, oh, it has got a strong positive relationship. That is, by increasing this, I can reduce the cost, then I have a positive relationship, because anyway I want to reduce the cost, but by simply increasing this, I can reduce the cost, not here, yeah, the cost, then I will say there is a positive correlation between these two metrics. That is, by increasing one, I can actually move the other one also in the desired direction, then there is a positive correlation. So, I can change any one of these to get the desired movement. But if the other way, if I increasing this, the weight increases, then I have a negative relationship, because I want to reduce the weight, but when I am increasing this, the weight increases, then I say there is a negative relationship. So, like this, not everyone should have a relationship. Like this, whenever you have a relationship, when there is no relationship, you can put it as a 0 also, or you can give it blank. Same way, I can identify for each metric how it is actually affecting the other metrics in the whole system. So, this is the correlation matrix. So, here I am trying to find out what is the relationship between individual metrics, and when I change a metric, how the other metrics get affected can be shown in this diagram. So, you can actually show it as a plus, minus, depending on the requirement, you will be getting this. So, this chart gives you a complete picture of the whole thing what we have identified so far. It gives you all the information in a single sheet, and that is why this is known as the house of quality, and it looks like a house, that is why it is known as a house of quality. Okay, with a roof on the top and then the rooms and the foundation, it shows like a house. So, we call this as the house of quality diagram, which summarizes all the information whatever we collected so far into a single sheet, and which can be used for analyzing all the needs, metrics, benchmarking information, the direction of improvement, the technical difficulty, target values, everything can be put into a single sheet. So, that is the house of quality diagram. Thank you. Everything can be put into a single sheet. So, that is the house of quality diagram. Thank you.